In this video, we are going to discuss about design, simulate and implementation of universal shift register using Verilog HDL. So the apparatus required for implementing this one is Xilinx Vivado, is 2017 edition, and the FPGA which I am using is Basis 3 kit. Okay, so this procedure, how to implement how to synthesis in the program, I will discuss in later. First we will discuss what is universal shift register. Okay, so the universal shift register, first it will do the 4 functions, right? The first function is whatever the value we are giving in the input, that will come to the output, right? So that is similar to parallel in, parallel out. Okay, the second one is either it will right shift the value, and the third one is it will left shift the bit. Okay, totally I am having a 4-bit number, means suppose if it is for example 1000 means if I want to right shift means it will be 0100. Okay, suppose the values input is 0100 and I am going to left shift means it becomes 1000. Okay, so one is parallel in, parallel out, another one is right shift, and another one is third one is left shift, and the fourth one is whatever that we are giving it in the input, it will not change the output. Okay, the output will remain same whatever if I change the input. Okay, so that is called as no change. Okay, so this 4 function it is done by a universal shift register. So in order to select any one of this 4 function, I am using a 4:1 multiplexer. Okay, 4:1 means 4 input, 1 output and 2 selection pin. So if the selection pin is 00 means it will perform any of the 4 function, right? Either it will go for no change or right shift or left shift or parallel in, parallel out. Okay, so this the output value goes to the D flip-flop, and it require a clock pulse and clear pulse. So if the clock is 1 means the input value goes to the output. Okay, so this is a very simple connection. So if I want to shift the value to the right means so this is 0, this is 1, this is 2. So what it will do means the value here, it will go to the output, and next the value it will go to the out 1. Okay, so whatever the value here, it will go to the out 1. Okay, so whatever the value in the out 0, it will go to out 1, and out 1 will go to out 2, and out 2 value goes to out 3. Okay, so this is a value of this is a function of right shift. Okay, if I want to perform the left shift means you can see here, this is a left shift function, right? Which one is this is a left shift function. Okay, this is your left shift function. So sorry, so this is your left shift function. Whatever the value in out 3, it will go to this out 2, then out 2 value it goes to out 1, out 1 value it goes to out 0. Okay, so this is your left shift. Okay, and similarly for the no change, this is your no change function. Whatever the input, it will remain as it is. Okay, whatever you are giving as input, it will not affect the output. Okay, so the out 0 value is again going to the this one. Okay, input. So this is a function. So let's see the program for how to write the program in VHDL. Okay, so what are the inputs are there in inputs? You have pair in 0 to pair in 3, then selection pin, selection 2 pins, and selection right shift and left shift. So totally 4 plus 2 plus 2, and clock and clear, then that's it. Okay, so 4 plus 2 plus 2 plus 2. Okay, these are your inputs. So you have 4 output, right? And you can see this this out 4, it acts as a in and out pin. Okay, so you can see. So what are the input? Clock, clear, 2 selection pin, and 4 input pin. This represents 0, 1, 2, 3. Okay, this is your MSP and this is your LSP. And the output pin, you have out 0, 1, 2, 3. Okay, okay. So this program is written in a behavior model. So it should start with always at passage clock. Since it is a sequential circuit, it is better to write in behavioral model. Okay, so the clock, whenever the clock signal goes from 0 to 1, that is your passage, the input will reflect in the output. Okay, so if clock is 1, if clear pin is 1, my output goes to 0. All the output, 4 outputs, right? 0 out, 0 to 3. The 4-bit binary value is 0. Else, okay, if clear, now the clear pin is 1. So if that is the case, based on the selection, if the selection pin is 0, 0. Okay, so if the selection pin is 0, 0, whatever the output you are giving, it will not change. Okay, so that is what it is representing. When it is 0, 1, when it is 0, 1, that output is equal to pairing of 0. Okay, pairing of 0 and pairing of 0, comma, this is concatenation value. Okay, pairing of 0, comma means concatenation. Concatenation means combining. Okay, so the first so the first value comes to the right hand side value comes to the left hand side. Okay, and third, second, and first bit will move to your right. Okay, so this is similar to a right shift. Okay, this function is similar to a right shift function. So if I want left shift, means the selection pin you have to choose it as 1, 0. Since it is selection 0 and 1, so 2-bit binary value I have selected. Out is equal to the right hand side, 3 bits will come to left side. Okay, and the third bit will goes to the right hand side. Okay, dead end, that is dead end of the your right hand side. Okay, so this is your right shift function. Okay, when it is 1, 1, whatever the input we are giving, that should reflect in the output. Okay, this is your parallel in, parallel out. So this is your end case. You have to since I have opened a case, you have to end the case. For begin, I have to put one end. For this begin, I have written one another one end. For module, I will close the module as end module. Okay, and next you have to write a test bench for this program, and the test bench is nothing but your what are the values that you are giving. Okay, so you can see you have to start with module and module name. Then instead of input, you have to change it as a register. Okay, here whatever the input, you have to change it as register, and output you have to change it as wire. Okay, then you have to call the module name. Okay, module name of universal shift register, that is shift right register. You can give any name, followed by this what are the inputs they have given: pairing, selection, clock, clear, and out. Okay, so you have to map. This is nothing but a mapping function, followed by initial begin. If clock is equal to 0, that should repeat 100 nanosecond, and after 20 nanosecond the clock is equal to inverse of clock. Okay, so for till 20 second 20 nanosecond it is 0. After 20 nanosecond it remain 1. After 20 nanosecond it will goes to again 0. Okay, so this function will repeat of till 100 nanosecond. Okay, 100 times. Then I'm going to give the input, right? So you have to give the input for the clock. I have given already the input. You have to give the input for the pairing, right? This is your input 1011, and the selection pin I have chosen as 10. So 10 means it is a left shift, right? 10. Then clear pin I have to give it as 0. Okay, if I give 1 means the output goes to 0, right? So if it is 0 means it will perform the left shift. What is the left shift value? Left shift value is 0 11 111 0 111. Okay, so similarly for after 40 nanosecond I have given another inputs. Okay, pairing, selection, clear. This 11 represent I think what are the input that will reflect in the output. Okay, so this is your parallel out, and this is your the no change value, and for 01 this is your right shift. Okay, so end module. I hope you have understood this universal shift register.